A very good morning to all of you present here. Welcome to the ATAL Faculty Development Program on Cross Modality Innovation, Generative AI in Language, Image Intelligence, and Medical Advancements. Now we will proceed for session of final day, a hands-on session on customizing large language models for specific use cases. It gives me immense pleasure to extend a warm and heartfelt welcome for this session to our esteemed resource person, Dr. Supriya Bajpai, Physics Research of India, Bengaluru. Today, Dr. Bajpai will guide us through practical exercise designed to deepen our understanding of large language models. We are truly honored to have you, ma'am, for today's session. Over to you, ma'am. Supriya, ma'am. Supriya, ma'am, are you able to hear me? We are just connecting in a while. Please.
Hello.
She's
Now,
Yes,
responding.
am
yes,
I audible?
ma'am. Yes. Yes, ma'am, you are audible. You can
Okay.
start with the session,
Once
ma'am.
again,
Thank
once
you.
again, I once again I would like to thank the organizers and HOD Dr.
Thank you,
Deepika
ma'am.
Kumar ma'am and Rakhi ma'am, Gargi Mishra ma'am for
Thank
inviting
you,
me to
ma'am.
this FDP and share my expertise and knowledge. Uh, so I think we should start now.
Yes, ma'am. Yes, ma'am. We
Okay.
can start.
Yeah. So today we will have a hands-on session on LLM and RAG uh, area. Because I would like to I would like to join people in this session. Um, I'm just opening my collab notebook. So anyone who is having this Google account, they can easily run these codes. So this is my collab notebook. You can open it by just going to Google Collab. Open this one like Google Collab or Welcome to Collab. Just sign in by using your Google account. And you can open the notebook. So I had already opened this notebook. So suppose this is the Welcome to Collab and you can open from here. Suppose open, just you will have to log in through your Gmail account. Once you are logged in, then everything is fine. And next is to open a new notebook. So you can, so this collab is connected to the Google Drive. You have a space in the Google Drive, and also you have the runtime, RAM, etc. They provide us for free. And this is like new notebook you can open if you had already, if you have already existing notebook, you can open that one, or you can upload notebook from the system. So going along with this session, this is my, suppose I opened this new notebook. So today first we will see how we can run the basic llama, or like any LLM we can use, but I'll go with the llama version of the LLMs. And also I would like to highlight that since this is a Google Collab, Collab notebook, so I'll be using just the smallest model available in the llama, that is 8 billion. So I have this notebook here. So first thing is like we need to install certain libraries. So I'll start with this pip installation. So here I'm installing pip install sentence transformer, transformers, and ChromaDB. So maybe we can keep this for future. Right now, I will install only the sentence transformer and the transformers. So what are these sentence transformer and transformers? You can go to just Hugging Face. mm, Sentence transformer. So now Hugging Face is a this provides us large number of transformer based models for creating the embedding, like sentence embeddings. So this is like all mini LM. There are different types of all mini. This one, if you open this one, they are listing all the mm, models available. So why Hugging Face? Because this is an easy platform where we can get and use all the embed models for language models for easy embedding generation, as well as for we can use this. Hugging Face also provides us for the all the large language models, so that we can easily combine it with our model. So this is like a model. These are the list of the models, like sentence transformer. These are different BERT base. This is all mini. You can see like if you go to some, suppose any of these models, you can see how many parameters or anything is, like everything is listed here. How it works, you can see just like so. So like information is given here. You can see all the and choose any one of the models for creating or embeddings. And we will also use the second one is transformers. So these sentence transformers um, are for creating the embeddings of the uh, query and the text for RAG. So and this one transformer we will use for the large language models. So let us have a look at all the transformer models.
Excuse me, ma'am.
Yes.
Please be a bit slow as we are implementing with you.
Okay, okay, okay.
Okay. Thank you, ma'am.
Okay. Okay, uh so now we will look at the transformers. Just go to the transformers. Hugging Face, because Hugging Face is providing all the models at one place. Hugging Face. Yeah, this is a Hugging Face transformer. So if you just type transformers, it will show something like this, because there's different transformers, also a movie and something. So it's better to at least write what you exactly want. So we want Hugging Face transformer auto model for causal LM. So this is language models. So causal language models we want, that is the large language models basically we are looking for. So if you type this one, so it will show like auto classes. And so let's go here. Sorry. Yeah. So from here we can see the different types of models, like Google BERT. So if you use this thing, autoconfig.pretrain Google BERT base uncase, so it will use this Google BERT language model. Similarly, there are different Llama. Let me check where is Llama. Uh, you can also type like Hugging Face, Llama. So like Llama has many versions, 3.1, okay, 8 billion parameters. So they like Llama has released in 3.1 like 8 billion, 70 billion, and this is 450 billion. And like different versions, like um, which is some versions are quantized, some are not quantized, and like different labels of quantization is done. So we will select the latest releases, Hugging Face. This is Llama 3.2, but we will use here the Llama 3.1. So you can type and so yes, one thing I'd like to highlight that if you want to use these large language models, you will have to fill a form here on the Hugging Face. So mm okay, so I had already filled that form. So in the here some form will appear if you log in with a new account. A form will appear here. You will have to just write your name, organization to which you belong, and your email ID. You will just get a link to your email ID, and they will verify it. Then you can use this different uh, um, LLMs and different transformer models. So okay. So Llama 3.1. So this is like Meta Llama, Llama 3.8 billion. So now coming back to installation. So now we will install the sentence transformer and transformer. Sentence transformer for for creating the embeddings of the sentences, and transformers are for the large language models. So let's start. Okay, so one thing also we need to keep in mind that runtime here. Uh, so we can change the runtime. So this is CPU only. You will get a free T4 GPU, but all these others are, I think, on purchase basis or something. So A100 GPU generally is good, but first I'll show you on a CPU. If we require, then we will have to switch to the T4 GPU. Or let's check with GPU. So okay, I'm just choosing this GPU and start with the work. So changing this runtime will restart everything, delete everything, whatever was in their runtime memory. Now next is okay. So uh, so now I will import the certain libraries. So I'll mainly focus on right now, like from sentence transformer, import sentence transformer for sentence embeddings, and transformers. This is for large language model, auto tokenizer, and auto model causal event. So this is, I'll explain it later on when we proceed in this code. Okay. Okay. So let's do one more installation, PyPDF2. Why we are doing it? Because this can read a PDF. Just to read any PDF. Mm, from here, just go to code, select another cell, and then, sorry, since it is giving warning that I have occupied this GPU, but I'm not using it. So maybe start pip, pip install PDF2. Okay, let me comment this one first. So first, first we will discuss like how to answer a simple query by using the base LLM. So base LLM, okay. So for base LLM, just I'll start from here, defining the main function. I'll explain to you line by line. Okay, so starting with first I will initialize this model, and DB it's just a function name. So I'll first initialize a model only. So initializing a model is I am choosing the model is Meta Llama 3.1 8B instruct. So it is uh, not this one. You can write this one instruct. Why the instruct? What is the difference in Meta Llama 3.8B and 3.18B instruct? So if you only use Llama 3.18B, it is like difference in the not the methodology actually, like how they are actually trained. And so they are basically trained with different types of this is the basic model training. If you use this model, only this one, this is like basic training. After that they are instruct means they are trained with the instructions also, like one more layer of um, training has been done to this model by so that it can understand the instructions of the user. Like suppose I ask him do this, do that, so these are kind of instructions. So it understands it better, and it is trained to perform the task according to like user instructions. And overall also it performs better than the Llama 3.18 billion basic model. So this is like this is 8 billion is the smallest one. So since we are using the Google Colab, we don't have access to big GPU. So just I'm using this, the smallest model. Yeah. So model ID is this one. We are using this from the Hugging Quiz. We are using this model. Yeah, HF token. So like to use this model, we need some tokens so that we can like create, we can talk to this model, and uh, like it is just kind of API for API, we can get this thing. So these tokens we will have to generate. How to generate it? Just go to the, yeah, suppose I want the tokens for this. We will have to generate the tokens just one, and we can use any of the models. So it's like suppose we go to this one. There is form that I had already told you, okay, that there is a form you need to fill it and submit it, and then you will in like within 5 minutes you will get the authentication. If it is a official email, then you will get the authentication faster. If you will use your personal email ID, then maybe it may take some time, but I think I don't know how much time, but yeah, maybe one day. Yeah, so once it's done, you have to go to the access. Okay. Hmm. So I just logged in. It got logged out. So now when you go to this access tokens, uh, so you can create new token here. Just give a simple name, like whatever name you want to give, like your name also, like suppose Supriya, you can give. Upriya. So this Supriya also you can give. And create the tokens, fine grain read write. So with different permissions, you can create like write also. And just create token. So once you create the token, this is the token. Just copy it and you are done. So you can keep this token separate at one somewhere in one file so that you can use it again. So like here I have just write fine grain. So if you want to run these run your code with these tokens, so it's better to take this write permission. So there was suppose 3 permissions here, read write. So it's better write, go to the write, create, give some name and create token. Once this token is created, yeah, so once this token is created, you can write it here. And now the next thing is model. You just give the name which model you want to use. You created the tokens and then tokenizer. So tokenizer and model. This is for the large language models. What is tokenizer and model? So first see this model. So model is we had already seen that I'm taking this model from these libraries, auto model or causal LM from pre-trained, because I want to use the pre-trained LLM. I don't want to train uh, LLM again. So just write the model ID, device map, and user authentication. So like it will create a, this is a like API and it will create interface. So device map, what is device map? So device map auto, I'm just writing it for so that we can use it on the use it with the GPUs. So what it will do, it will automatically parallelize the whole this code means this a part of the LLM to the GPUs. You need not to do anything else. It will automatically, like whatever, how many if 4 GPUs are available, it will distribute it according to like whatever is available. So tokenizer, yes. So right now we are not using tokenizer. I'll tell you later on. So this is like I'm taking the return function, tokenizer and model. So tokenizer and model, I'm initializing it. So now the next function is so tokenizer model we got it from the return function, and then now generate the response from the model. So now I want to give a query. So suppose this is query, where was Albert Einstein born, and I want to give it to the LLM, this query, tokenizer and model. So what is tokenizer? Tokenizer is, now it will, what it will do, it will create the tokens of this these words. So like where is one token, was one token, the Albert Einstein born, like one word is one token kind of, but not it's not always. Like if we have suppose 1 2 3 4 5 words, but we can have like large number of like more than 5 tokens. So it is like we are it will just, what tokenizer will do, it will tokenize all the words in the sentence or in a paragraph and feed it to the model. So here we are giving query, tokenizer and model. Now let's see. So to the generate text function. Generate text, what it will do, we have, this is you have to write a generate text function. You can name it differently also. So it will give the query and the tokenizer and the model, and now the LLM will generate the answer according to the query. So this is the function for generate text. So we are giving the prompt. Prompt is like query. So why prompt and query are different? Actually, not query is like if you give some query, but you can add some instruction and add some additional content, so it becomes prompt. And tokenizer. So this is auto tokenizer from the pre-trained model. So it is using the model. So it is using the same model, MetaLlama 3.1 instruct, and it will tokenize the whole paragraph or whole sentence, whole prompt into large number of tokens, and this output will be the tokens, not the questions, or not the uh, means English. So so given all these things, so here you have to there are some, like, prompt is there, tokenizer is model you have given, maximum new tokens, and I'm leaving this device Kuda. So maximum length and maximum new token. So what is this maximum new tokens? So this is like maximum new tokens is the input plus the generated text is the combined, this is the combined thing, and this is maximum new tokens which you want. Suppose I have written 200 words or 200 tokens, sorry. So my LLM will give response in 200 words, and if the response exceeds the 200 tokens, then it will automatically truncate it, like it will not produce the result. And maximum length is given the uh, prompt plus the mm, like output of the LLMs. So suppose I am giving this, where was the Albert Einstein born? So I want the system to generate, LLM to generate answer in just 200 tokens. So this is like, this is 200, it will generate answer in 200 tokens. And it is not necessary that it will cover the whole answer in 200 tokens. Whatever answer will lie beyond these tokens, it will truncate it. So you need to choose carefully this and maximum length. So like maximum length is kind of a fixed thing, so you need not to choose this, you need to choose this. This is the crucial thing. So maximum length is the prompt plus, so like if my prompt is just a query, so where was this much plus whatever uh, extra I want the LLM to generate. So it is like 1 2 3 4 5, so 512 minus 5, this much tokens the LLM will generate. We are giving just a limit to it, and after that, like, it will use padding and on all these things. So now input is tokenizer. What is this tokenizer? So now this is the function, and in function, what is the tokenizer? Tokenizer, we are giving the prompt, this one question, and the return tensor is equal to pt. Pt, why? Because we want to use the PyTorch model. So this is pt means PyTorch. So it will give mm, means the so like it will give the tensor of otherwise you will get the arrays. So like it will convert the tokenized output into PyTorch tensors. Otherwise, if you don't use this, you will get a list or NumPy arrays, or which we cannot use with the PyTorch model. So you need to keep in mind that you need this PyTorch tensors. Now you can directly use the input. So after using this tokenizer, you will get all the tokens of the query, like prompt. And now, yes, so once we get the tokenizer, then output model dot generate. Now it is given to the uh, model dot generate, means now the LLM will generate the response. Generate means model dot generate, like model, which was the model was our llama 3.1. Now it will generate the response. We are giving the input, maximum tokens, padding, it depends on like what you want to set, and then outputs. And now the output is in output will be decoded, because output is not in the form of text. Output will be in the form of, suppose this is the, I have written here. So tokenizer, like suppose tokenizer dot decode will convert such type of arrays or tensors to something like this, like, so it will convert the arrays of numbers or to back to the text. So it will decode the numbers to text. So now we will take the return whatever text we got from the LLM. So basically, if you look at this function, what we are doing, we are giving the prompt, we are giving the prompt to the tokenizer and receiving the tokenizers, and then we are giving these tokens to the model, means prompt tokens or the query tokens to the model, and then model is generating the answer and decoding it, generating the answer in the form of numbers and like arrays or the PyTorch tensors, and then it will decode it to the text format and return the answers. So now return function will return the text answers. Here you will get generate text and you will get the LLM response. You can print it here. It will take too much of time because I'm just showing you, because GPUs are not that good here. So this will work, the other one will not work. Yeah, this will work because here I had already connected to the runtime. Let's see. Yeah, T4 GPU we have. So like LLM takes a lot of time to answer because they have large number of parameters. This is the smallest one, 8 billion only, but still it is taking too much. And also like we are not using some good GPU, we are just using this T4. It is this time is taken only for just running one query. So you can imagine if we do some bigger task, then how much time will it take? So basically, this import request, so what this does, it is just for requesting some, suppose I want to read some URL, suppose this one only. I want to read this page, then we will need to send a request to, and yeah, so like after that's why we are using this request, and all the things are like JSON. If we are using some JSON format, then we can use this. I think right now we don't need this one and all these things. For now, this is the only important point, and OS is like for reading the previous reading the files and all directories. So since you can see that we are this is taking too much of time, so in the meantime, I'm just telling you like For the other cases, we will use the grok. So what is grok actually? So if you just go and see what is grok. Grok, grok, grok. Okay. So like if you go to G- grok, you can, I don't, this is like GPUs are there for running, parallelizing the codes and running everything. So this is like they are saying that they have made their first kind of for language models. So for language models, they are using this grok. We need to create some API, and it will make the inferencing fast. So what is inferencing? Like we are, whatever we are asking the LLMs. Suppose I'm asking this query, and I'm waiting. This is like I'm just using the model for inference. I'm not training it. I'm not doing anything else. Just asking the query and getting the response is like what inferencing. So for inferencing, they make it very fast. So what you need to do for this grok? So mm, so this was the first, whatever we are running is just answering the query and using the base LLM for uh, inferencing. Now the second I'll show is the grok. Grok is like that what I already told, like it is a language processing unit. They are saying that okay, we are using it for the language models. It will make the inferencing very fast. So they provide an API key for this one, and you can use this API key so that everything will be, the query will go to their own cloud servers, and the LLM will run there, and it will just give you the response. So this is Grok. So for this, we don't need any GPUs because since everything is done on their servers, only thing is like we cannot use some private data or some like anything. If we have private, we cannot query. Suppose in the context I'm giving uh, mm, a query, and in the context I'm adding some chunk of data for the, suppose Fujitsu a company, I'm adding some private data. So that we cannot do because it will go to their server, and like it is not security wise, it is not secure. For general purpose and research purpose, we can use it. This They have some like you can run uh, for some time. There is a limit, like how much queries you can run using this grok for free, and after that you need to pay and buy the things. So yeah, see, it's still running. So what actually it is doing? So so this code was just for inferencing, that we are just taking the query and giving it to the llama, and this API generated. So this query is going to their server. This is not anything we have, because we don't have this model on my own laptop device, or like in the GitHub, since this Google Colab is connected uh, uh, to this sorry, not to this drive. So we actually we should have download, if we want it on our local machine, we should have downloaded this and install this llama 3.1 to this drive, but we are not doing it. We are just using the API key and running this query on their server. So llama is not on our server, it's not on our laptop, this is on their server. So We are just creating the API and talking to the llama, which is already present there, and just asking the query. It is calculating, performing the computations on their server and just giving us the response. So actually for computations, we are using this T4 GPU here of the Google Colab, but the model is on their server. So yes, I think it is taking too much of time. So okay, so it will generate answer. I don't know when. So I'm just stopping this code for now, and I'll show you by using the grok, like how fast the inferencing is. Because right now it is using this collapse T4 server, and for grok, when we will use grok, it is like grok server. So I'm just stopping it. It was almost done, but still I don't know. Now I'll change the runtime from GPU to CPU. I will use this grok. Pip install grok. So this is the they also need to generate the API keys for using the grok. So API key for grok you can create by going to the console.grok.com. Yeah, so console.grok.com/keys. So for this you will have to first log into this their means create just an account on the grok, and then you can go to the API keys here. You can create some new API key. So I had already created, but okay, you can also create new API key. Display a name, just display a name, suppose Supriya, and submit. You will you will get one more. Yeah, so you can copy this API, the similar to as we used as created for the Hugging Face. So just done. And you can use now this API key here. Yeah. So client is just creating a client for so that we can talk to this grok. This is just an API key. So just keep this API key, create a client, and this is get text. So this function you will have to use uh, uh, for getting the answer from the llama using their server. So it's like get text. You just give the query to this function. It will this client will chat with the things. So these are the important things. So here you will have to define this model, that is which model we want to use. So they also have list of models. So actually model was 3.18b instruct what we were using, but here it is instant. So because they have done some quantization or something, so it is very fast. It is faster than uh, instruct model. So this is instant, it will give a fast inferencing and return this thing. So now I'm just copying it. I will explain you from here only first. Yeah, so write a main function. It is very super easy. So this is just to write a query. Suppose query what where was Albert Einstein born, and just get text. Give the query to the get text. Query to the get text means here get text function was already they had provided. So this is just prompt. Prompt means query or with some addition instructions or just the query. So get text is simple. You will get the LLM response. So let me copy this and try this one, like how fast is this one. And like keep one thing in mind that we are now using CPUs. So we had changed the runtime, so I think we need to install it again. Yes, we had already installed. Yeah, so this was the code from Grok, import Grok, and then use the API keys for client, and then give this function so that Grok can generate and give the answers. Just you have to like write here which model you want to use, which LLM model, and then query, and then get response from this function only. So let's see. Yeah, it's done. So see, it just provided the answer. So if you look at the answer, what is the answer? So message completion content is Albert Einstein was born in some kingdom of Prussia, German Empire, this, that, and this. Okay. So why this much of answer? This much of answer. Okay. So yeah, okay. So yes, whatever was required, it just returned. Yeah, query time is also given here. This one, and total time is 0.04. Like, so yeah, so and we are using our CPU. So this we can also to use these large language models by using the Grok API. We can run it on our laptop also, CPU laptop. No need for GPUs. Mm. So next is before going into RAG, I'll show you what how this embedding of the sentences is made, and just an example. So example, sentence embedding generation, how we create the embedding for the sentences, and maybe one example for how we use the Chroma database for using for RAG. So I'm just copying. So sentence transformer, import the sentence transformer. This is a library, and then model. Model you can use any depending on small, large, whatever you want to use. So from sentence transformers, you can see here. So we had I had already showed you like Hugging Face. Just type the Hugging Face sentence transformers. It, if you want to just Hugging Face sentence transformer model. So it is like you can go here And see, there is a list of like a data set is one thing, but you want these models. So you have different large number of models, whichever you want to use. So like there are some small embedding models, big embedding models, depending on your task, they are trained differently for different tasks. So I'm just using any like this one. So all mini LM L6 version 2. So this is like a small embedding model. Now we have some of sentences, the list of sentences. The weather is lovely today. It's so shiny outside. He drove to the stadium. So these are like 3 lines. And I want to create a embedding of these sentences. So it's like embedding a model dot encode. Model is go to this transformer and call this one encode sentences. So now you can print the embedding shape. So embedding shape, or you can print the embeddings also. So I'll just write this portion. Go to the collab. Yeah. So let's see what it gives. Just not the shape. Sorry. I'll also embeddings. Yeah, so embedding shape is 3 into 3, 84, 3 because 3, there are 3 lines. So for each line, it is creating a vector of 384, means size of 384. So it is like, yeah, so this is a, from here to here, this is the embedding of the sentence, the weather is lovely today. So since this like any model cannot, all these language models, they don't understand, system doesn't understand the text, it understands only the numeric values. So these embeddings are like just converting this means words or text into a numeric form. So it is not done randomly, actually it is like there is a lot of like how uh, what is the semantics they keep in lot the minds, and a large number of things in mind. And for example, these sentence transformers are using the transformer model. Transformer model means there is a kind of self attention mechanism which is used in these models because they are very good for semantics context generation. So those models are used for this means they are trained with different with for embedding generation and understanding the text. So those this model is they are using from the sentence transformer to create the sentence embedding. So there are models also for word embeddings also. So just it will create the embedding of just the weather, it will create the embedding of is. So these are like word embedding model, but here we are using the sentence embedding because mm, not always, but like in here in this case, in like when we ask some queries, so it is better to take these sentence embeddings. So here you can see like how 3 sentences are converted into uh, vector into 3 vectors of size, I mean dimension 1 cross 384. So yeah, so it was just an example of how we are creating the embedding of any sentence or suppose any chunk of data. So I'm saying that, okay, this is the chunk of data. This is just one paragraph. Okay. So it will create the embedding of, suppose you give some paragraph, it will also create the embedding of paragraphs. So now the next thing is Chroma Devi, but yes. So what is actually Chroma Devi? Chroma Devi is a uh, database. Actually, it is a vector database for storing the embeddings of the like text. So For example, one database you can think of like tabular databases on there, and for which you can use the SQL queries and all that. But these databases are different from those because they don't store it in a tabular form. It is for the embeddings for, and they are optimized for retrieving those embeddings, doing the similarity search, like different types of operations which can be done on the embeddings of the sentences or paragraph or words. So all these are optimized for doing all those tasks. So this is just one Chroma database. We can we So first thing, like why I'm telling you what is this database, because now I want to use that RAG system. RAG is retrieval augmented generation. So yesterday I had given you some idea of RAG. Maybe we can just in a couple of lines I will just revise it. Okay, suppose you have some document, company specific or company private document. You just don't want to use their APIs. So what here we are doing, we are just suppose calling the client. We are using that Grok API. So everything, our query and our data set will go to their server, and everything is like run and we get the response. But our data, we just leaked our data and to their servers, and we don't want to do that. Like if our data set is private, we don't want any data leakage or some like we want to play safe. So one thing is like we can one the best option is we can download all these things, means this LLM, not this sentence transformer, that the llamas, we want to download and install the llama in our server or on our laptop and run this, and run. For that we need some GPUs, our private GPUs. So one thing is this, and but here we are using the Grok. So Grok for faster inferencing. Here we need not to download or install any large language model. Yeah, so this was about the Grok. And for Chroma DB, why we are doing that? Suppose we want to ask some questions, which I already told you that we have private data set and private documents, and I don't want to show it. So what we will do, we will use the our own servers mm, for this llama and llama inferencing, and we want to ask those questions from a certain document. Because see, llama or other large language model don't have the don't have the information of is whatever is there in the private document, but we want to query that private document. So what we need to do, we need to give the large language models those private documents and then ask them queries, and they will, what they will do, they will go and see and retrieve the information from those documents, and then make some good English, and then give the answer back to us. So it is kind of like keeping the some domain specific task. First thing is like we talked about the hallucinations. So it will stop the hallucination if we like yesterday we asked the question about how many employees are there in the uh, Fujitsu. So the LLM was hallucinating. It was giving the wrong answer. So now we want the correct answer. So for that we will need to provide the information of document information, like whatever uh, is for the Fujitsu, like maybe somewhere there is mentioned in that document that there are this number of employees. So we can provide those documents along to the large language model, and then we can ask the question. Then it will provide, then it will not hallucinate. So it is kind of this is the system for RAG. So now Chroma DB is one. Uh, no, so for what we need to do, first we need to we cannot directly feed the whole document to the LLM because the document size is very big. So suppose we have 1,000 pages of like hundreds of documents with 50 pages or 100 pages each. So we cannot provide all those documents directly to the LLM because they have some limit on the context length. So what they will do, so what we do, we just chunk the document chunking means like divide the documents in suppose small paragraphs, and then uh, and then use a retriever to ask the query, and use the retriever to retrieve only those chunks, only those paragraphs which have the information, actual information. So we will retrieve those information and then provide it to the large language models. So it will be within the context length of the LLMs. We can provide as a prompt and context, and then LLM will correctly answer. So retriever is like for retrieving these, whenever we are using these chunks, like creating one paragraphs, then we need to create some embedding for similarity search. So for that we need this vector databases. So suppose list all the vector databases. So you can see like there are FAS, Waviate, Pinecone, Chroma, and all that. Elasticsearch, like Elasticsearch is good one. Chroma DB is good one. So so you can not this one till I think uh, these are like more this one with this Pinecone, Chroma, Quadrant, Elasticsearch. All these are like good. So you can use. So here I am using this Chroma. So this is the Chroma database, vector database. So for this, we need to first pip install, do the pip installation, which I think I had already done. Just pip install Chroma database and create a client to so that you can talk to this Chroma database. And then there's a collection. What is collection? So suppose you make a folder. If we make a client, so suppose you make a folder. Just think of a room. There is a room that is known as a Chroma database, and now you want to store the embeddings of suppose this line one, this line two. So suppose these are different documents. I'm saying this is the whole document. This is the whole document. So and these are like two different, very different categories. So we can say that okay, this is one in a room there is one carton. So this is one carton where you can store the vector means vector embeddings of all means of one document in then the vector embeddings of in if in a different carton you can save the vector embeddings of different document kind of. So we can make many collections. It is like a room, this is room and this is carton, so you can store the things. So now how it is stored, so it is stored like a cluster of information. So suppose few lines which are more similar to each other, they will be clustered together. So whatever we do like clustering kind of thing. So uh, it is all done when you store in this Chroma database, because this is already, I told you that it is optimized for such tasks. So it automatically does all those things for easy retrieval. So now this collection, so suppose it is just an example. I'm just writing this one here and showing you what it gives. I think it will not give anything because we've installed ChromaDB. So now it install the yeah, successfully installed. Now now we want to yeah, I don't So if you, I'm writing this code on, so since this is embedding is already, if you want to change the embedding model, you can change all those things. So it is by default, this all mini LM6, this is, it is using for the embedding generation. So let me just tell you what exactly was the RAG, so that you can understand it better. Um, yeah, this last slide. Suppose we have some document. Suppose I'm saying in the document there is just one PDF file, huh? So you need to chunk the PDF file. Chunk the PDF file means just take 200 words each and say that 200 lines. So 200 lines is one chunk. Then next 200 lines is the another chunk, similar, and like so and so on. Just create the embedding of the one chunk, then second, third, and suppose there are n chunks. So create the embedding of each and every chunk. So here you can use the embedding models like I have shown you for the sentence embedding uh, generation models. From the sentence transformers, you can use any one of those model, any one of those uh, embedding generation model. So just create, it will create the embedding of each and every chunk. And now it will go to the store vector database. Now this is my chroma. I'm saying that this is my chroma database. And if you store this embeddings of all the chunks, embeddings means that is in some numerical format. So it will look like, suppose this is the first embedding, second embedding, second, first embed, first, sorry, embedding of the first chunk, this is the embedding of the second chunk, and so on. So suppose n chunks. So now once this, it is stored in the chroma database, we are saying that, okay, my documents are now embedded and saved in some database. Now user asks a question, okay, what is the how many employees are there in Fujitsu? So it will go to the this chroma database and do the similarity search for the uh, for this query. Okay, suppose which chunk is most similar to this query. So since this is optimized for such semantic searches and all those things and indexing, so we need not to do anything. We just put the similarity search for this one. Ki, okay, now this for this query, it will do the similarity search and retrieve just one to any top k chunks. Like we can, that is a hyperparameter. We can choose, like suppose I want just the top one chunk. So it will give just one chunk. Suppose the first one is the most similar to this query. So depending on the embedding, so for the question also it will create the embedding, because we can do the similarity search only by using the embedding. So it is do the similarity search, retrieve the one embedding document, and then along with the query, like query as well as the chunk embedding, which is retrieved from this vector database, it will give it to the LLM and ask it to generate the answer for this query using this information. Kind of, it will ask like, okay, this is the query, but answer is provided uh, in this chunk size. So LLM will create some answer in the proper language, and then it will deliver it to the user. So this is the actual rack system, how it works. So now this is what is the chroma we are using. So now for the chroma, we need to first chunk the documents and store it in the database. Chunk the documents, create the embeddings, and then store it to the database. So first thing is this one. So first we will see how we do this, uh, this only task, like only this. We will take a document, we'll chunk the document, create the embeddings of the all the chunks, and then store it in the database. That's it. And whenever we will, whenever some user will, this is like, this can be done one time. This is a one time task. If you have some fixed database, ki, okay, this is the Fujitsu's all the documents, we just create and save one vector database, and anytime the user comes and asks a query, it will go and retrieve the most similar chunk and give it to the LLM and answer. Each and every time this can be changed depending on the, this portion can be changed depending on the user query, but you can fix this portion. So first we will see how we do this task, the upper one. So for creating the database, since we for creating database we don't use any LLM. So, okay, what we need is, first is the database, chroma database. So I am just defining the path of the chroma database. So since I am just creating the folder in the runtime, so it is saved when the runtime restarts, it will be destroyed. So I'm just creating it here. You can create it in some another folder. You can give some path XYZ, but I'm not giving it. So now this is just two lines for if they if already if already exists, then remove the existing database folder. So now the first thing is you need to create a client. So for client, so this is the path of the database where you want to create the database. Since you are creating this database not on some server, you are we need to create this database on the local machine. So one thing, why I am using this Chroma database and not the other like Pinecone or others. So they have some, I think they can work on the cloud also, like FAS. They have their means their whatever is saved in the this vector database, it will be on their cloud. But right now I am using my local machine for storing the document. Since I'm saying that my document is private, I don't want to disclose it or send it to some other server like other people's server. So it is like we are I'm just using my local machine, so that's why I'm using this Chroma database. So for Chroma database, yeah, so this is like a client, so that we can talk to this database folder, whatever we have created the database. So this is the client, give the path of the folder and persistent client, and then collect, this is the collection name. Suppose we can make any number of collections in the same folder. So suppose I'm making one, since I'll show it on just one PDF document. So for the whole PDF document, I'm making one collection. You can give any name to the collection, like Supriya collection, something, anything. These are the metadata, means whatever metadata it automatically stores, let it be. So for the collection, we create client dot create collection. So when we will create the collection, it will be create collection. Otherwise, it will be get collection. Whenever we want to retrieve the data. Right now I am storing the data, so this is create collection, and when I'll retrieve the data, it will like it will be get collection. So I'm writing the collection name and metadata, whatever it is. So if you want to see, like, just print the collection name or make, you can just print. You can by printing you can see like how many collections are there in my database. And this is the embedding model. Why we are using this sentence embedding model? Because for the chunk embedding, we wanted to create the chunk embeddings here. Uh, so these were the chunks. For after chunking, we want to create the embeddings. For this, we need some embedding model. So, so here we are using this MXBAI embed large there are a large number of different models. As I had already showed you, you can choose any model from there. So this is the embedding model from sentence transformer for creating the chunks of the embedding. Now I'm just uh, returning this client collection and embedding model. So first thing is we need to, now I will start from the main function. Since we have a PDF document, so I'll read the PDF document. So for reading, I have written this function, simple function. Okay, not this one. Yeah, read PDF from file. This will use this PyPDF tool and PDF reader. So this is used to read PDFs and means read PDF and extract the text content from the PDFs, because PDF may have images and tables and all those things. It will extract the read the text material whatever is there in the PDF. And yeah, this function is just to read the PDF. You can see like by page, for every page it will read the pages and extract the text and then uh, append it to the text, and we will get a document. So this is like this whole function will uh, extract only the text portion from the PDF and create a list of the, like for every, yeah, so it will read one suppose document PDF. And if we don't want to read from the PDF, we can use any document from the directly web URL. So if you want to use this URL, just give the URL and read the documents from the web page directly. So I will provide you this code. This is a very simple one. Yeah, next is, yeah, we started from the main function. So read the PDF first, and then get the client collection and embedding model, because we need the chroma DV and the collections whatever we had made for storing the embeddings of the chunks in the vector database. And this is the embedding model. Now first we create the chunks. So split into chunks, we had already defined one function above, that it will split the chunks into, so I am saying lines per chunk means one chunk will contain 10 lines. So it is like dividing the whole document in 10 lines of paragraph each, and we say one paragraph as one chunk of 10 lines. So it will divide the split the document in chunks, and then it will read and then it will this chunk embedding, what this is doing, this is creating the embedding of the chunks. Like suppose there are 4 chunks. uh, I'm saying that my PDF has suppose 50 lines, so it will be like 5 chunks. So 5 chunks, it will create the embeddings of the 5 chunks and store it in code. It will do the create the embedding and store it in the documents chunk by chunk. Like for one document, now the document will have one chunk, second chunk, third chunk, and till 5 chunks embedding. So now the embedding is created, and so here the embedding is created in this line. Now we need to store this embeddings to the chroma database collection. So what we are doing, we are just this chunk by chunk, we are this embedding is equal to chunk embedding, and then we are creating the chunk embeddings and saving it to the database. So here this these lines of code you can use to store in the collection vector embeddings into the collections whatever you had generated here. So now this part is done. Okay, you have first read the file from the first read the PDF, then uh, create the chunks, and then create the chunk embedding, and then save it to the collection. So like 4 tasks done. And for this, you need some embedding model. So you have defined it under function. You need the collections. So you have like how you have created the collections, and client is just so that you can talk to the Chroma database. So let me run this code. So since this is not using the any LLM, so like there is no inferencing, it is just chunking, creating embeddings and saving it to the Chroma database. So, oh, okay. Yeah, so this is, yeah, we can remove this one because it has already been done. Yeah, so for this, first we need the PDF. So where to, since I'm just using my runtime, so this is one PDF. This is a very small PDF because since I'm using the Google Colab, so I just want to keep everything like smaller. So this is the PDF. This is just one page. This is my, so this is a paper, first page of the paper. So now I'm just, this is the paper. I'm just dragging and dropping it here. So now we got this one paper. Now it will create the Chroma DB automatically. We run this all file. Yeah, so PDF content read successfully. Connection name is connection build. Collection name is collection 1. And number of chunks is 4. So 10 lines is it's like 40 lines. So if we want to, so here you can see that it has created a Chroma DB folder. And these are the like metadata collection and the metadata. So it's done successfully. So it created, it just chunked the whole file in 10 lines each, created the embeddings and created the embeddings of each chunk and saved it in the Chroma database. Now information is saved. Now we want to retrieve the information. Suppose I want to ask a query. Yeah, so I'll not do the inferencing using uh, means using the base this LLM using their API. What we are doing, I'll use the Grok. So for faster inferencing, so now what we need to do, we had already created the vector database, saved everything. Now we want to ask a question. So where it is, so start with the main function. So I want to start this question at what are the research challenges given in the document, or just what are the research challenges kind of thing. Now it will create the, first we need to, since now I want to uh, give this query, create embeddings of this query and do the similarity search from the vector database, like which chunk is most similar to this query, and retrieve it and give it to the LLM. So now I want to perform this task. So this is the query, and now we create the embeddings of the query. So embed model, whatever we had used from the sentence transformers, So here I am using this embed model. We had already described this initialized models. So in this model, we are this using defining this embedding model. Which embedding model we are using? This is from sentence transformer, and this is the client I'm creating, and collection. For collection, there I was using the create collection. Now I am using this client dot get collection because it is already created. So now query is asked, query embedding is generated, and then this is performing the query, means this is doing the similarity search. So this whole portion is doing the similarity search. This is performing the query. So it is going to the collection dot query, query embedding, that is embedding, and then it is asking for end results, means top one chunk you have to retrieve. You can change it, you can write suppose 5. So it is saying that okay, top 5 chunks, retrieve the top most similar 5 chunks, or now I'm saying just give one chunk of data. And this is query chunk similarity. This is like a query embedding results. Now it will retrieve, this portion is for retrieving. This will do the similarity search, and then retrieve the last one, means top one document, one chunk. You can see and print this query chunk similarity, like which chunk is, yeah, like how many, which lines are it is giving. So now we have the query, and we have the query, and we have the chunk, top k chunk, similar chunk, means the inform, we know that okay, in this chunk, this in this answer of this query lies. So now the final prompt, we make a final prompt so that we can give it to the LLM. How to give the query, means the top k chunks as well as the query to the LLM. So this is like answer the question using the information provided in the this chunk. So like use this chunk for answering the question, and for if there is some instructions are there, so follow those instructions strictly, and query is this one. So query is this one, and answer lies here. So you have to create one just final prompt and give it to the LLM. So here LLM, for LLM I'm using this Grok. So I need not any tokenizer, I need not anything. So I just give it to the Grok on its own server. It is doing everything. It will run the large language model, generate the answers, and just give it the response to us. So you can print and see the response. Yeah, I'm just copying this one, and let's see what answer it gives. So Chroma DV1 collection is collection 1. Okay, so it should run. Let's see. Yeah, so inferencing is very fast since we are using the Grok. So if you look at the first is the like query, we had printed this query chunk similarity, like is the uh, which chunk has the information. So here it has selected this chunk, like where application of deep reinforcement learning, Indian stock trading, Pay, this research, Monash research. And since the document was very small, and our Llama is also not that good model, so I'm not saying that it is definitely giving the correct answer. So LLM response is this one. So it has chosen this chunk size, this chunk, and from using this chunk, it is answering to the query. So let me go slowly. So messages, chat completion messages, content. Unfortunately, the document does not explicitly mention specific research challenges related to the deep reinforcement learning in the, means it is saying that However, based on the abstract provided, which mentions feature extraction and trading strategy design, all these things, like whatever it inferred from the so it is creating its own answer. Okay, from there is no direct answer for what is the research challenge, but yes, from whatever I have read, I can tell you this. So this was for the grok. So this was RAG. So suppose if we want to, so here I have used this PDF. You can also use the any web page, like you can use web URL. So there was, yeah, in place of using this function, you can use, yeah. So since I was reading from the PDF file, from the local file path. So this is I was using this function. If you use like any read PDF or something from the web link, so you can use this one, where you need to just define the URL, give URL as an input, and it will read and do the same task, like it will create the document, means it will read the PDF. So yeah, that this so now next is, so next thing is like we can see if we how we do the inferencing of this using the LLM. So yeah, so we already have this Chroma database created. Now we want to retrieve the answer from this by using the local LLM. So if we want to use the local LLM, the inference mechanism will be same, like similar to what we had already seen. So it is like first initialize this model and databases. So since client is the create a client and create a collection, now get the collection, not create the collection. I want to retrieve the document, so I'll use the get collection. And we need to define here model, like llama model, which yes, we also need the tokens for using this llama from the Hugging Face. So why I have written like HF tokens, like Hugging Face tokens, these are, since we are using this uh, model from Hugging Face, whatever is provided by the Hugging Face, so we are using, so we need to authenticate, okay, like I am the user, I'm the genuine user. We need to define this tokenizer and the model, and then embedding model, like which model will use for the, but I yes. So why this one is also required, this is required for query embedding, because for chunk embedding we had already created, but for query embedding we will need this one. And generate text function, so generate text function will create the take the prompt, model, all these things, parameters, tokenize it, and then generate the answer using the uh, llama model, and then it will decode it, like from embeddings, from the embeddings to the text. So in the main function, client collection, we call all these things, and then query, like what are the research challenges in the document. This is just uh, like I had made the query with using, you can new line, you can use new line here also directly, no need of this doing this. So instructions, yeah. So one thing is like there is just right now I was using just one query, okay, what are the research challenges, but suppose I want to add some instructions or give some extra amount of information to it. For example, I'm saying that okay, use in the instruction, so it is like prompt template we can have. So instruction like provide the answer only for the question are generally LLMs small, like the models smaller LLMs have this hallucinate very much. So like llama hallucinates very much, so it always gives some extra information, uh, means not relevant to the question. So if you want to give some instructions to the model, okay, provide the answers only required, or do this, do that, like if anything else is required. So for that we need a prompt template. So you can define a prompt template here, and with the so instructions is given in the prompt template, like prompt template dot format. And now we create the embedding of the query, and do the query for top one. Like I want the uh, top one most similar chunk from this data. So it will do the this line query chunk similarity, like you embedding result document 00. So the what this is doing, this is retrieving the most similar chunk from the vector embedding depending on the query. So since here query embedding we had already provided here embeddings of the query, and also defining like how many chunks we want. So now it will give you the top one most similar chunk and the final answer for this. So since we are using this instruction also, so here we have already written like and follow the instructions strictly. So you can give this instruction not here, maybe you can write it something like instructions. Here just add instructions. Okay, it will understand, okay, this is the instruction. So this is the most similar chunk, this is the query, and I'm saying follow this instruction given in this template. So in the template, uh, if suppose I don't want, means anything you can give. You can give one paragraph also, something, some extra information, like you give to the chat GPT. So suppose I'm giving one, suppose this many lines and asking it to explain what this code is. So kind of this whole chunk of code we can give in the template. So now it will print the so LLM give this final prompt to the generate text. What it will do, like final prompt, it will create the embeddings of this final prompt. First it will tokenize it, and then it will create the embedding, and then generate the answer, and then decode it and give back to as a response from the LLM. So we can see if it works, because earlier it was taking too much of time. Not sure if it will work, because we are connected to the CPU only, not GPU. So let it run first. We can see few more things. For example, okay, you have seen this databases, other databases, and also you can see like there are Ulama. There is this one from Ulama. So this is for the Llama. You can, this is very, so Llama 3.3 is also there. Okay. So you can, if you want to install this Llama on your local, suppose Windows machine or any Linux machine. So I have tried this one. No, I have tried this. This one is very easy. This also works depending on if you are not connected to some secure server, because most of the time, like if I tried this one, I couldn't download it because it was not letting me. It has some like security issues. So maybe this one, if you have Windows laptop, you can download this one. Download for Windows. Oh, no, I don't want this. Yeah, you can go to models here. So Olama is like will provide all the embeddings and either the sentence embeddings or the large language models, everything here from the Olama. It is kind of interface. You can download it, install it very easily. So these are the Llama 3.3. It has like this is 70 billion. Llama 3.2 Vision, Llama 3.2, 3.1, Mistral. So yeah, like and yeah, like encoder based models and in decoder based models both it has for embedding generation and also for LLMs. There are also, yeah, these are all. So if you want to just classify embeddings for embeddings, so these are embeddings. So you have seen like I am using this one for my embedding generation from, I think, sentence transformer. Yeah, so for embedding generation, I was using MXBAI embed large V1. So, but I am using this sentence transformer from the Hugging Face. But you can also use like Hugging Face. This is Olama. Like from Olama also you can use. You can use either Hugging Face or Olama. One more thing. So these are vision models. You can see another tools. One more thing. There is also one thing. LangChain. First, let me check if it's done or not. No, it's still running. Ah, okay. So similarly, so this is LangChain. You can also use this interface for using the large language models and embeddings and means just type LangChain. Yeah, from the tutorials, build a simple LLM application. You can use this interface is like for provide this is very easy interface, like you will get everything together here only. By using LangChain you can perform all the tasks, like you can choose any LLM, and it is just an interface, like you can use an LLM, you can get it from the LangChain. You want any embedding model or do any retrieval task kind of thing. So these are the important things. You can further, like if you want to explore, you can explore all those things. Like it is a kind of ocean. Every day something new is coming. So just go and read everything. I'm just showing you what else is there, which you can easily use for your research purpose. So it's still running. I think uh, I don't know how much time it will take. Yeah, so I think I'm done. So this was all which I wanted to tell you all. I would like to take any questions from any of us, any of you.
We have now reached the
Yeah.
query session of the program, I guess. So
Yes,
Priya
because
ma'am, yeah,
yes, yes. Yeah, it's
I,
done. From my side, it's done because that one is
okay.
taking too much of time. Yeah, and I'm not sure that it will show some result or it will just abrupt abruptly like disconnect or something will happen.
Okay. We have now reached the query session of this program, this particular session. If you have any questions, please feel free to ask. Kindly raise your hand and we will unmute you. Participants,
Yes, Jyoti ma'am, I'm just doing it. Jyoti ma'am, you can ask your query. You can unmute yourself. Okay,
Yes,
thank
ma'am.
you.
Thank you. First of all, Supriya ma'am, thank you very much. It was a wonderful session, and we
Thank
have
you.
learned a lot. And I have one question. When we are passing the information, when we are extracting the information from the vector database, right?
Okay.
Right, and we're still passing that retrieved information to the LLM.
Yes.
Are we still not leaking the data?
Yes, we are leaking data because right now I'm using the Grok. But if you are installing and downloading the LLM to your own server, then we are not leaking. Since I have used like here APIs, you have seen for the Hugging Face API I'm using, and also for the Grok I'm using some API.
Right,
But for
right,
the Chroma database, this is on my local server. As you can see that it is here, not on some other server. We cannot see where is our LLM. Can we see here? No.
no.
It means that it is like someone else server that if we are passing the retrieve data, it is getting someone else server. But for the Chroma database, whatever information we are storing, this is on my own like git what is a drive. This is on my own drive. And the second thing, if I use the uh, if I download and install the model here only, then it is like kind of safe. We are not leaking anything. That says you are saying that okay, how much time it is taking. It is not possible to download and show the local llama here.
Right, right. So that means there would be a time constraint if you're running it on a system.
Yes, depending on like uh kind of, yes, like depending on like what is the configuration of your GPUs.
Okay,
See,
but
for
does it?
at CPU, I think it is not possible. I'm not sure. You can ask a simple query also,
Okay. Okay, so
but
that means if you want to
on
keep the
GPU
data safe, we have to install it on our system and run only.
server, yes, system or server, anything, yes,
Okay, all
both
right.
the things. Like vector database, also you have to create on your own local server or local system, and also the LLM you have to download and use it on your local machine.
Yeah, but when we are just importing that Chroma DB, it is there on a system only, right?
Yes, right now, like here you can see this is
This is
in
on
my
our system only.
system. Huh.
Right, right.
So whatever query is going for retrieval, this is going here only.
Okay, and when the answer that you got for the first question, what are
Hmm.
uh, the question about the research paper that you asked?
Yes.
So the system was still hallucinating, right?
Yes, because the first of all, I was using just this PDF. If you look at the PDF,
Mm.
let me show
It
you.
was a
If
single
you look,
page document, right?
yes, yes, this was a single page document, and research challenges was not clearly defined here in this paper.
Mm.
So, yeah, and also I asked just one chunk. I retrieved just top one chunk, maybe. So it just used like 5 lines something in the abstract. This chunk it retrieved. Maybe the answer was not there in any of the chunks, but it's retrieved the just top one chunk and made its answer somehow. But maybe it was not correct because first of the llama is a very small model. 8 billion we are using. So anyway, llama will hallucinate always.
Okay, so which
In
model do you suggest that we can use for, creating
so
something like chat PDF for our own system?
So the best one is like GPT-4. It has something 175 trillion parameters, something like that. But then it is like you will have to buy it. It is not for free.
Okay.
If you want to create a API on using that GPT-4, it is
Hmm.
like they charge some like 0.1, 0.2 some dollars, like for a fixed number of tokens. Like it is dependent on like how much token you are giving. So it is costly, not that cheap.
No free model is really available for that then.
GPT-2, I think it is freely available, but that is very bad.
Okay.
Like, yes, for free, this is Minstrel is also, I think, free. That is good. Llama is good. But if you use the Llama, one is Llama 70 billion, 8 billion, 70 billion, and the other one is, I think, 100 something billion parameters, not the trillion. So you cannot compete with the trillion models. Like Llama is just a billion model. If you see Llama
And also it said that
3.0,
it is just going to read that PDF thing is just going to read the text data and not the tables and the images, right? So it only work on the text part.
yeah, yes, yes. So no, it's like kind of research. If you want to retrieve all those things, you will have to use some other function, or you will have to see like how it retrieves the tabular data. It is not same as the text data. And
Okay.
also how it understands, that is these LLMs doesn't perform well on the structured data. So this is kind of research topic on in itself ki how will you make the LLMs to understand, and how will you feed the information of the tables, because we cannot directly feed tables to the LLMs. I'm not talking about the chat GPT, because chat GPT is like uh, they don't disclose like whatever they do. So it is trained on like different types of they have done different types of training, large number of data sets and some human feedback. But llama, and these are for research purpose, so it's like these are you cannot give the structured data, and if you give somehow the structured data, it is like research thing, will it understand like how you give it to the llama so that it understands and make use of it.
Okay. Thank you very much, ma'am.
Okay, thank you.
Any other query from participant side? I guess no queries.
Now, would this Google Colab be shared for practice with us?
Yes, I can share it with you.
Thank you.
Okay, so on behalf of organizing committee, I would like to extend our heartfelt gratitude to Dr. Supriya for her valuable contribution to our FDP. Your hands-on session was highly engaging, ma'am. Your practical insights and interactive approach not only enhanced our understanding of the topic, but also provided us with practical knowledge that we can apply in our respective domains. Thank you once again, Dr. Supriya, for sharing your expertise and for being such an inspiring speaker. We hope to have the pleasure of collaborating with you in future as well. Thank you, ma'am. Thank you so much.
Thank you, Gargi ma'am. Thank you, Rakhi ma'am. Thank you, everyone.
Thank you so
Yes,
much,
Dr.
ma'am, for
Supriya,
connecting.
I would like to
Yes,
also thank that it was a, even I was looking into it. It was very good session. It was very technically enhanced, and you were showing the practical approaches very brilliantly. So thank you so much for joining us and accepting our invite.
thank you, Deepika ma'am. Thank you. Thanks a lot.
Mhm.
I was also honored.
It's being tough. So we are almost about to end this program. Rakhi ma'am, please.
Yes, ma'am.
Mm.
Okay, thank you so much, Supriya ma'am. Now we will start the valedictory session after 5 minutes, 5 to 10 minutes break. And please stay connected as we will share the test and feedbacks also after the valedictory session. You can have the you can join the valedictory session after 10 minutes. Thank you all for joining the session today, Despite of holiday, thank you so much. And we have learned a lot of things in the hands-on session. Thank you. Please stay connected. We are starting in 10 minutes.